Hey there and welcome. Today we're going to break down a classic physics mix-up, the difference between speed and velocity. I know, they sound like the same thing, but you're about to see how the entire difference boils down to just one simple, crucial idea. Let's get right into it. So let me ask you this. You're cruising down the highway, you look down, and your speedometer says you're going 60 miles per hour. That's your speed, right? But believe it or not, that number alone doesn't tell the whole story. It's missing a key piece of the puzzle to be your velocity. All right, so to really get the difference, let's start with the one we all think we know from our everyday lives. Let's break down the basics of speed. So when you glance down at your speedometer, what you're seeing is your instantaneous speed. It's literally how fast you are going in that single instant, whether you're flying along at 50 miles per hour or you're stopped at a red light reading 0. But think about a real trip, say to school or to work. You're never going one constant speed, are you? Of course not. You speed up, you slow down, you hit traffic. Your average speed just smooths all of that out. We just take the total distance you covered and divide it by the total time it took. It gives you one clean, simple number for the whole trip.
Okay, so speed is just how fast. Seems simple enough. So what is the big deal with velocity? Well, it turns out the whole thing hinges on just one extra word, one extra piece of information.
And this right here. This is the absolute key to everything. Now, I know what you're thinking. What on earth do scalar and vector mean? Don't worry, it's simpler than it sounds.
So check out this table. A scalar quantity is super simple. It's just a number. It has a magnitude, which is just a fancy word for an amount, like 10 miles or 25 miles per hour. That's it. But a vector adds that second crucial piece of information, direction. So it's not just 10 miles, it's 10 miles north. That direction changes everything.
To put it another way, asking, what's your speed, is really just asking, how fast are you going? But asking, what's your velocity, is asking, how fast are you going and in what direction, you see? To fully describe velocity, you absolutely have to include a direction, like 55 miles per hour, heading east. All right, theory is one thing, but let's actually put this into motion with a couple of examples. This is where the difference between speed and velocity really clicks and becomes crystal clear. Okay, picture this. A physics teacher is pacing around their desk. They walk 4 meters to the east, then take a right turn and go 2 meters south, then turn again and go 4 meters west, and finally take one last turn and go 2 meters north. The whole trip takes them exactly 24 seconds. So let's break this down. The distance the teacher traveled is pretty easy, right? You just add up all the parts of their path. 4 plus 2 plus 4 plus 2, that gives us 12 meters total. But now we have to think about displacement. Displacement is just the change in position from the starting point to the ending point. And since the teacher walked in a perfect rectangle and ended up exactly where they started, their displacement is 0. And this is where it gets really interesting. To find their average speed, we take the distance, that's 12 meters, and divide it by the time, 24 seconds. So we get 0.5 meters per second. But for average velocity, we have to use the displacement, which was 0. And 0 divided by anything is 0. So even though they were constantly moving, their average velocity for the whole trip was 0, because from start to finish, they didn't actually go anywhere. Wild, right? Okay, let's try another one. Imagine a football coach just pacing back and forth along the sidelines. He starts at point A, moves 35 yards to point B, then turns around and goes 20 yards back to C, and then turns again and goes another 40 yards back to point D. So what's his total distance? We just add it all up. 35 plus 20 plus 40. He walked a total of 95 yards. That's a lot of pacing. But his final position is only 55 yards to the left of where he originally started, and that's his displacement. You see how distance and displacement are telling two completely different stories about his motion?
Okay, so we've seen the concepts in action. Now let's get our hands dirty and actually run the numbers. It's time to do some math.
The good news is the calculation is pretty simple, and it follows the same 3 steps every single time. First, you figure out what you're measuring. Are you looking at the total distance for speed or the final displacement for velocity? Second, you find the total time of the trip. And third, you just divide. Just remember, distance over time is speed. Displacement over time is velocity. Let's try one out. So Lisa Carr is on vacation and travels a total distance of 440 miles. The trip took her 8 hours. The question is, what was her average speed? This one is pretty straightforward.
We just take her total distance, 440 miles, and divide it by the total time, 8 hours, and that gives us an average speed of 55 miles per hour. Simple enough, right? Now, this doesn't mean she was going exactly 55 the whole time, but that was her average over the entire journey.
Okay, now for one that's a little trickier. A cross-country skier is moving back and forth, and they cover a total distance of 420 meters. The whole thing takes 3 minutes. But because of all that turning around, their final displacement is only 140 meters to the right of where they started. Let's find both their average speed and their average velocity.
All right, let's run the two calculations. For speed, we use the total distance, 420 meters divided by 3 minutes. That gives us an average speed of 140 meters per minute. But for velocity, we only care about that final displacement, so we take 140 meters, divide by 3 minutes, and we get 46.7 meters per minute. And we can't forget the direction, to the right. Look at that huge difference. Same trip, two completely different answers.
Okay, let's bring it all home and wrap this up with a quick summary. Think of this as your final study guide to make sure these concepts are locked in for good. So let's boil it all down to the 4 biggest takeaways. Number 1, speed is simple. It's a scalar, just distance divided by time. Number 2, velocity is the one with the twist. It's a vector, which means you calculate it using displacement over time. Which leads us to number 3, velocity always needs a direction. Always. And finally, number 4, just remember that physics teacher walking in a circle. You can be moving really fast and covering a ton of ground, but still have an average velocity of 0 if you end up right back where you started. So, the next time you're walking, or driving, or even just riding your bike, think about your path. You might be moving pretty fast, but if you're taking a winding route with lots of turns, what's happening to your actual velocity? That's the power of knowing the difference.